In this video, we're going to find the maximum revenue for example 3, and we're going to find the maximum profit for example 4. This is going to take a little bit more energy and effort than the previous problems, so let's get started. A business sells 2,000 units of a product per month at a price of $10 each. It can sell 250 more items per month for each 25-cent reduction in price. What price per unit will maximize the monthly revenue? I think in a previous chapter you remember that I came up with a linear equation rather quickly, and I did it without having to show any work. However, I struggled quite a bit. And I said there is an easier way so that you don't have to struggle, and it's called finding two ordered pairs and writing a linear equation. That's what we're going to need to do here because we're talking about revenue, and revenue is equal to the number of units you sell times the demand. So remember that your price function, which is lowercase p, is equal to what we call demand. And in an economics class or business class, they will call that demand, not price, but it is the same thing. So your price per unit, that's your demand. We also need to recall that revenue, well, I already said that revenue is equal to X times P, that our ordered pair is going to be X comma P for the information that they're giving us in the problem so that we can replace lowercase p with an expression in terms of X. The reason being is we have three variables. We know that we want to maximize monthly revenue, so we want to find the price that's going to maximize monthly revenue. We're going to find that first derivative of revenue. However, we can't do that when we have two different variables that it's in terms of. So we're going to have to replace that demand or that price function with an expression in terms of X. So where are we going to get that from? Well, we're going to have two ordered pairs here. We sell 2,000 units at $10 each. So that ordered pair is 2,000, comma 10. We also sell 250 more items per month. So that's going to make that value go to 2,250 for $9.75 per unit. So for each 25-cent reduction in price, you sell 250 more items per unit. We're going to write our equation using p minus p prime equals the slope times x minus x, not prime, p minus p1 minus m times x minus x1. This is no different than y's in place of the p's, but we want to keep everything consistent with our price, so I'm going to try not to say y. So we're going to have p minus 10. I'm going to use this ordered pair, and now I have my slope. My slope is going to equal, I'm going to try and do this color-coded. My slope is going to equal, let's make that a little bit smaller so I can fit this in here, 10 minus 9.75. So your change in your output, 10 minus 9.75 over your change in your input, and then that's going to be multiplied by X minus 2,000. So we're going to have P minus 10 equals 25 over 0.25 over negative 250 times X minus 2,000. Now I'm going to do some arithmetic here that I hope that you can follow. This is going to be the same thing as 1/4 times negative 1 over, it's going to be 1 over 4 because that's what 0.25 is, times 1 over negative 250 times x minus 2,000, and then I'm going to add that 10 from the other side of the equation. So P equals negative 1 over 1,000. I just brought the negative up to the numerator, times x minus 2,000, and then plus 10 is still on the outside. I'm going to distribute that negative 1 over 1,000. Negative 1 over 1,000 times x is negative 0.001x, 1,000th x in the negative, plus 2,000 times 1 over 1,000 is 2, and then plus 10. So our demand function is negative 0.001x plus 12. So our revenue function is x times negative 0.001x plus 12. I can distribute this and I can move forward with finding my first derivative using the simple power rule, which is exactly what I'm going to do. So my first derivative is equal to negative 0.002x plus 12. I set that equal to 0 because I want to find the maximum. So I take the first derivative, set it equal to 0. I've got 12 equals 2 over 1,000x, which is the same as 1 over 500. I multiply both sides by that 500, and I get 6,000 equals x. You can do the math. Now that I've found what x is equal to, I can go and determine the price per unit. Remember, the price per unit is your demand function. That's your price per unit. Look up here where I'm drawing the arrow. Your price per unit is your demand function. And your demand function is the linear function we just found off to the right. So price is equal to negative 1 over 1,000 times 6,000 plus 12. So negative 0.001 times 6,000 plus 12. I just made it a fraction because I work a little bit better with fractions. Negative 6 plus 12 is equal to 6. That means $6 per unit is the price that maximizes monthly revenue. And that is the answer to that question. So if you need to rewatch the video to find out how we found that linear function, we just pulled information from the problem to give us ordered pairs. We found that linear demand function. We used that linear demand function into our revenue definition so that we could come up with a revenue function that we could find the first derivative of because we wanted to maximize monthly revenue. Okay, let's go to another problem. Finding the maximum profit. The marketing department of a business has determined that the demand for the product can be modeled by, they give us a demand function. This is wonderful. That means it's not linear. We don't need to find it on our own. It's given information. The cost of producing X units is given by an equation that they provide us right here. What price will yield a maximum profit? So now we're talking about profit. What does profit equal? Profit equals revenue, all the money that you take in, minus all of the cost. Profit is equal to revenue minus cost. Well, we know that revenue is the number of units sold times the price or the demand, and then minus our cost function, which is provided for us in the problem. So our profit, which is a capital P, is equal to x times 50 over the square root of x minus all of the cost, which is 0.5x plus 500. Make sure you subtract all of the cost and not just part of it. Profit is equal to 50 over, not 50 over, 50 times the square root of x minus 0.5x minus 500. We want to maximize profit, so I have to find the first derivative. but I'm going to need to eventually find the price that's going to yield the maximum profit. So I'm going to find what that maximum profit is. I'm going to find the maximum number of units by finding the first derivative of profit. So 50 times x to the 1/2, I'm going to come off to the side. 1/2 times 50 is 25, and then subtract 1 from the exponent. I get negative 1/2, so I'm going to put that over the square root of x. Minus 0.5 is just 1/2. I'm going to set that equal to 0 and solve. 25 over the square root of x is equal to 1/2. The square root of x is equal to 50. I'm just going to hang on to that for a minute. I can say, okay, well, x equals 2,500. If you're not comfortable with that, that's fine. But I'm going to show you why I hung on to that, because I need to find the price. So let's come over here and do this in a color that that's going to stand out to us, that you're not going to be able to miss. The price that's going to yield that maximum profit is going to come from 50 divided by the square root of x. And the square root of x is 50. See, so just by keeping that as the square root of x, I can just substitute 50 in for the square root of x, and I get $1. $1. The price of $1 yields, that means provides, results in a maximum profit. And that's our answer. Hot diggity dog. Now, there was something I was going to say, and I don't remember what it was, but I wonder, maybe if you rewind, maybe I've already said it. Maybe you could figure out what I was going to say. I don't know. I do not know. I just remember that when I was coming over here and I had the square root of x equals 50, there was a thought that went through my mind. I think that's it. I think that's it. The price of $1 yields a maximum profit. So that's the end of this, and I think that you've got enough that you can get some practice in on this and hopefully feel a little bit more comfortable with that. Revenue is equal to the number of units you sold times the demand, and that profit is equal to revenue minus